Let's compare the scaffolding division algorithm to the standard long division algorithm. We'll compare the same division problem, 1,104 divided by 4, with both methods. On the right, the long division algorithm has one correct solution path. In other words, I had to choose a 2 in the hundreds spot to get the right answer. If I had written down a 1 in the hundreds spot, it would have thrown off my work and I would have ended up with the wrong answer. With the scaffolding algorithm, you can see that I've provided 2 paths to solutions. There are often many solution paths with the scaffolding algorithm. That means that one student's work might not look the same as their neighbor's work. If you've done it correctly, you should end up with the same answer. The different solution paths are dependent on the multiplication facts that you chose to use. I can choose the ones that I'm most comfortable with. What happens then is that sometimes the scaffolding algorithm can be quite inefficient, meaning that we can write lots and lots and lots of lines of work to get to the answer. Whereas in the standard long division algorithm, it tends to be quite efficient because we're dealing one place value at a time. Let's look at another problem, 950 divided by 5. On the left, with the scaffolding algorithm, we know that we should stop when we get down to 0. This is because we're dealing with the entire dividend, the entire 950, and we subtract off until we get down to 0 or some number less than 5. With the standard long division algorithm, getting to a 0 doesn't mean we've gotten to a stopping point. Because we look at one place value at a time, in this case the 0 meant we were down to 0 tens, but we had not yet dealt with the ones place, so we had to keep going until we had a 0 in the smallest place value.